Hello students, this is Shri Guru over here. Welcome back to my YouTube channel. Today in this video we are going to discuss about some elementary derivatives of differentiation terms. Now look at the first one here, differentiation of x raised to. These differentiation terms you will study detail in a mathematics. Okay, but anyhow, to derive some kinematic equations we require these terms, so that remember these equations, how we can differentiate the different functions. Okay, here x raised to n is a function. We are going to differentiate this x raised to n with respect to x, then that become n x raised to n minus 1. After the differentiation, x raised to n become n x raised to n minus 1, where this n is a number 1, 2, 3, 4, 5, 6, like that number. Okay, then here the second differentiation of a raised to x with respect to dx, then it become a raised to x log a to the base e. Okay, similarly where this a is a number and x is a term. Okay, now differentiation of e raised to x. E raised to x is an exponential function. Therefore, after the differentiation, e raised to x with respect to dx, it remains the same, e raised to x only, right? Similarly, fourth, differentiation of log x to the base e, then it become 1 divided by x. Okay, next, differentiation of sin x. Now this is a trigonometric function, right? When you differentiate sine function with respect to x, then it changes to cos x. Now look at here another differentiation of cos x. Differentiation of cos x become minus sin x. Okay, but here differentiation of cos x is sin x is cos x, but here differentiation of cos x is minus sin x, right? Next, differentiation of tan x with respect to x, that gives secant square x. Shortly I have written here sec square x. Okay, next, differentiation of sec x with respect to x, sec x into tan x, right? Next term, differentiation of cot x with respect to x, minus cosec square x, minus cosec square x. Next, differentiation of cosec x, minus cosec x into cot x, right? How this changes, don't think about it. Here these all the derivatives you will study in the mathematics chapters. Okay, just remember all this, how these functions get changed when they are differentiated with respect to x, right? Note down or take the snapshot of this board. The next important equation is integration equation. It is exactly reverse order of differentiation. Okay, as we did in the earlier x raised to n, we have differentiated with respect to x, but here we are going to do the integration. This is symbol representing integration of x raised to n with respect to x, where this n is a number. Then this is equal to, when you integrate this with respect to dx, then it becomes x raised to n plus 1 divided by n plus 1 plus c. This c is representing constant term. Remember this or take the snapshot. Okay, now we are going to derive the kinematic equation on the basis of calculus method. Okay, whatever we use the terms, calculus means it is consists of differentiation and integration terms. Okay, as we have derived in the earlier kinematic equation, v is equals to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. all these equations now I am going to derive on the basis of calculus method. Right? It is one of the first equation. Let a particle change velocity dv. That change in the velocity I will represent as a dv. Right? Change in the velocity in a time. In a time dt. That dt is change in the time. Now the constant acceleration of the particle is given by, we know the acceleration. Acceleration is nothing but it is a rate of change of velocity, right? That is change in the velocity dv divided by change in a time. Correct? Now rearrange this equation. dv is equals to a into dt. Just I have taken this dt to the left side, then it becomes dv is equals to a into dt. Right? Now differentiate this equation. This a is what? Acceleration. That acceleration is a constant. Acceleration is constant. It does not change with respect to time. There may be a change in the velocity, but the change in the velocity is a constant at every instant. Therefore, a is a constant term. Remember, now integrate this equation. Integration for this symbol is representing integration of dv is equals to integration of a into dt. Is it right? Now see here, integration of dv, that means 1 into dv. If nothing is there behind the dv, then consider as a 1. Correct? If differentiation of this term, integration of this term always gives v. That term only, v only. Right? And this is equal to, as I said, a is a constant. We cannot integrate this. Therefore, take it outside from the integration. What the remaining term? Only integration of dt. Correct? That integration of dt which gives only t. Integration of dt is which gives only t. As we did here, integration of dv is v. Similarly, integration of t is dt is t. Right? Remember. And this constant, as we have to apply it for the integration c. That is integration constant. Right? Now we have to find out the value of c. To find out the value of c, what we have to do? When t is equals to 0, when t is equals to 0, if you substitute this value into this equation, then v is equals to the velocity at that time is initial velocity, that is u. Therefore, substitute these two values into this equation. Therefore, equation 2 become v is equals to t into 0 is 0 plus v is what? U into c. That gives u is equals to c. Right? Now substitute this value into equation 2. Therefore, v is equals to at plus, in the place of c substitute u. That is v is equals to u plus at. We have derived this equation. Note down or take the snapshot of this board. Now we are going to derive the second equation. Okay. Here I have written displacement of the particle after a time dt. Right. Let dx be the displacement of the change the displacement, right? Change the displacement of the particle in a time dt. Now listen properly here. Now we are going to write the velocity equation. Velocity is what? Rate of change of displacement, that is dx, displacement divided by time taken. Is it right? Now rearrange this equation. Dx is equals to v into dt. V into dt. Now see here. But dx is equals to u plus at into dt, because v is equals to u plus at. We know this equation, right? In the place of v, just replace with this term u plus at here. Correct? Now integrate the above equation. Integrate this equation. Next, what happens? Integration of dx is equals to integration of u plus at into dt. Correct? Or integration of dx, write it separately. Integration of u into dt plus integration of at into dt. Is it correct? Next term. Integration of dx is what? As I said earlier, integration of dv is v and integration of dt is t. Similarly, integration of dx is x. Integration of u with respect to dt. This u is what? Initial velocity of the particle. Therefore, the initial velocity, it does not change. It remains the same. Initial velocity. U. What the remaining term? If you take it outside from the integration of dt, correct? If you take it u outside the integration, then it becomes integration of dt. Integration of dt is what? T, as we did earlier, plus a. Take it outside from the integration. What is the remaining term? Only integration of t into dt, because I have taken this a outside the integration because we cannot integrate acceleration. It is a constant in this equation, right? Integration of t. For this, we have to apply a formula x raised to n. We know the x raised to n formula. If you differentiate x raised to n with respect to dx, then it becomes x raised to n plus 1 divided by n plus 1. We know this, right? integration of, in the place of x here only, sorry, integration of into dx. Integration of x raised to n into dx is x raised to n plus 1 divided by n plus 1. In the place of x, here t is there, right? If nothing is there over the t, then take it as 1, take t raised to 1. That means here the value of n is 1, correct? Then t raised to 1 plus 1, 2, divided by 1 plus 1, 2, plus integration constant, that is c, right? Remember this equation as a first equation in this derivative. Okay. Now I need the value of c. At time t is equals to 0, at the time t is equals to 0, what is the value of before the displacement takes place? The initial position of the particle is x naught, right? When t is equals to 0, the value of x is initial position, that is x naught. Substitute this value into this equation. X is equals to u into 0, 0 plus t square is nothing but 0. 0 into anything is what? 0 only. Therefore, these two terms become 0. The value of c is c. Keep it as it is. The value of x is what? X naught. Now we got the value of c. Therefore, x equal to ut plus, first I will write this as a 1 divided by 2 into a t square. In the place of x, c, here I will write x naught, right? Now take this x naught to the left side, then x minus x naught is equals to ut plus half at square. What this x minus x naught is representing? Change in the position, right? That change in the position is nothing but displacement of the particle. That displacement of the particle I will write as a yes, ut plus half at square. Remember, because s equal to x minus x naught. Okay, take the snapshot of this board. Okay, the last derivation, that is velocity attained by the particle after traveling a distance, yes, right? For this we should know the velocity equation. V is equals to dx by dt. We know this. Rate of change of displacement is nothing but velocity, correct? Multiply this equation, equation 1 is multiplied by dv and divided by dv. Multiply this equation with dv and divided by dv. Then v is equals to dx by dt into dv. First multiplied, next divided by dv. Correct? Rearrange this equation, or just simply uh, dx by dv into dv by dt, dv by dt, dx by dv. Just first I have taken here dv to the left side and here dt on this side. Interchange, I have interchanged this. But differentiation of dv with respect to dt, which gives acceleration. Therefore, v is equals to a into, this is nothing but a dx by dv. Correct? Because this dv by dt is acceleration. Now take this dv to the left side, then v into dv is equals to a into dx. If you don't know, write here, because dv by dt is acceleration. Right? Now integrate this equation. Integrate above equation. What happens? Integration of v into dv is equals to integration of a into dx. Correct? Now we can integrate v with respect to dv, but we cannot integrate this a with respect to x. We cannot integrate this. Is it right? Therefore, integration of v is, we can apply the formula x raised to n. Integration of x raised to n is x raised to n plus 1 divided by n plus 1. Therefore, if nothing is there, what we have to take? 1 in the place of v raised to, entire system is 1. 1 plus 1 is 2 divided by 1 plus 1 is 2. Correct? This is equal to, we cannot integrate a, keep it as it is. What is the remaining term? Integration of dx, because I have taken this a to the outside from the integration. Integration of dx is x. Integration of dx is what? Dx is x only. Correct? Now plus c, plus c. This is equation 2. I need the value of c. For that, when t is equals to 0, when time t is equals to 0, what is the initial value? V is equals to u. Correct? Just wait here. Okay, when t is equals to 0, v is equals to its initial velocity. Before going to particle start moving, its initial velocity is u. When time t is 0, the velocity is initial velocity. Therefore, if you substitute the value of v by replacing this v by u, then u square by 2 is equals to c. Correct? This becomes 0 because this displacement is what? 0. Therefore, substitute this value into equation 2. Substitute this value into equation 2. That become v square by 2. V square by 2 is equals to ax plus u square by 2, or otherwise v square by 2 minus u square by 2 is equals to ax. Just take this u square by 2 to the left side, then it becomes plus, it changes to minus here. Now take 1 divided by 2 common, v square minus u square. Take 1 divided by 2 to the left side, then it becomes 2ax, or v square is equals to u square plus 2ax. This is the final expression. Remember all these derivation. This is most important. Take the snapshot of this board. Okay. Okay. Thank you for watching my video. In the next video, we are going to solve some problems. Okay. Thank you.